Well, good morning, everybody. Glad that you're here. We've got a great show lined up for you. And for some of you, it's lunchtime. Some of you, it's earlier in the morning, but it's so nice to have all of you here for Construction Tech Edition. And you saw in the preview there, yes, the techniques, the technology, and the technical, we are going to dive into it. So let me pass it over from one co-host to another, but I'm Sean Sainamore. Great to be here. And boy, this is going to be a good one.
Yes, it is. Thank you, Sean, and Happy New Year, my fact friends. This is our first programming of 2023. We are thrilled to be here. We're very excited for all the changes this year. If you don't know me yet, I'm Shannon Pendleton. I lead Passive House projects at Sanderson Sustainable Design, and I co-host on this great show, Construction Tech. So I'm excited for today's presentation. We're going to learn a lot. We're going to dive deep, and we're going to get all your questions answered. And with that, I am going to pass it off to Mark.
My name is Mark Willey. I am super happy. I want to take this moment to thank Kim and Zach for the incredible new intro and the onboarding of a daytime series and all the epic things that we don't know that it took to get here. Incredible. This topic today is going to be fast, but when you see the technical, when you see the technique, when you see the technology, put a comment about what you're learning so the rest of us can get a feel for what you're experiencing. Without further ado, Kevin Brennan is next.
Thanks, Mark. Thank you, co-host. I am Kevin Brennan of Brennan Insulation and Air Tightness. I am here in New York City, where it's just about the afternoon. I welcome you all to the first Construction Tech of the year. We'll be working on Construction Tech the third Wednesday of every month in the afternoon. We plan on putting together a great program this year of great presenters that bring the technical, the technique, and the technology to the Passive House world. And today we bring you my good friend Cramer and Barry Price. So who you have on the show tonight, this afternoon, I should say, I have to edit myself, is Barry Price. Barry Price is a NCARB certified licensed architect and certified passive house designer. He has designed homes and structures in and around the Hudson Valley. Barry's designs elevate his structures from buildings to works of architecture, integrating modernism and high-performance building techniques and regional materials to achieve enduring compositions of light, space, and line. We also have my good friend, Cramer Silkworth of Bachcraft Engineering, is a professional engineer providing mechanical systems designs for energy-efficient buildings since 2012. He has done consulting, design, verification for residential small-scale projects. He has also taught courses in building science at Parsons, the New School for Design, the City College of New York, and RISD, as well as Passive House Consultant Design course for the Passive House Academy. So I met Cramer almost 10 years ago, and he was also working on some of the projects that I was working on as the air tightness or the XO air tightness, trying to achieve Passive House. And Cramer was always bringing the mechanical knowledge to the projects. He's been great to work with. He's been a mentor and a friend, a fellow educator that has shared with the community, and also a fellow aficionado of awesome shirts like mine. So Cramer, this shirt's for you. And I kick it off to you guys for a great presentation. The floor is yours, boys. Thank you.
Yeah.
Thanks, Kevin. Thanks, everyone.
Thanks, everybody.
So, high performance mechanicals. Super important that we start thinking about these from very early on in the design process. One of my favorite quotes from one of my favorite TV shows is, when you do things right, people won't be sure you've done anything at all. That's what we're aiming for here. Comfortable, healthy buildings that people can live in and not really have any problems. It's nice when someone will call back a year or two later and say, house is great, comfortable, air is always nice and fresh, no problems. That's happened maybe once in 10 years. What I do hear about are the opposites. It's too humid in here. It's stuffy in there. It's whatever over here. So people don't care about this stuff until something has gone wrong, because it's just not on their radar that these things are so important to our buildings. So we've got to be thinking about the systems that provide the heating and cooling and ventilation and dehumidification and all this other stuff from the very, very beginning. I hate turning people away, but people come to me with, permit sets and starting foundations tomorrow. And I say, I'm sorry, but you're really too late. I've got, months worth of work to do still, and we're trying to get caught up. But these things have to start from the very beginning, the space requirements for them and power requirements, access to and from outside are so important to consider from early on, and maintain that throughout the design phases and construction phases.
Yeah. So what is the beginning for a lot of people? They might think of the beginning as when you're starting construction documents, but we're really referring to the very beginning when you're establishing and setting up a project team to pursue the project. And I like to think about it in terms of trying to make it a proactive process rather than a reactive process, which we're all sort of scurrying around solving problems as they come up. And it's very easy to get caught in that when you're responding to the needs of clients and the demands of the process. So one way that I like to organize thinking about it, next slide, please, is just basically in terms of the standard phases of service that break down the development of a set of drawings and a project from the beginning. And I'm not going to go through them in detail. They're standard phases of service, but basically taking the HVAC system and understanding it and breaking it down from the beginning, from a programming phase, from a scale and relationships phase, the sizing and understanding of all the components, and then beginning to put them all together and look for conflicts, and then checking it all during construction. So the next slide, please.
So starting at the very beginning is really, you're putting your team together. And we're talking the beginning of design, when the architect and the client are first meeting. Some semblance of the HVAC systems has to be parts of those conversations. You may not know your builder until later on in that process, and then you have another meeting with them. But everyone has to be on board with all of the goals of the project. And if it's passive house certification or just code compliance or whatever, if you want a healthy functioning house, you've got to start early, and everyone has to understand the importance of these systems. If you are going for passive house certification or anything else, make sure that all of the requirements of that program are understood by everyone from the very beginning, and what that means from the design stage, but also the testing and commissioning of these systems as construction wraps up and people move into these buildings. Got to make sure these systems actually work. Tons of problems are found in the commissioning process. A lot of just little ones, quick little things, sometimes more major ones. I can only imagine what is happening in buildings that are never commissioned. As Barry said, early space planning. These things have physical size requirements. They're not magic coatings that we can just paint on walls and have everything perfectly conditioned in size. Heat pumps, ERVs, the ductwork, it all takes up space, and they all should be in certain areas of the building relative to what service they're providing. Making sure the client knows what these systems are going to be, what their maintenance issues are, what their controls are going to be like. A passive house is a very different building than what we're used to living in. And it's definitely a lot better, but you have to manage these expectations and guide the client through this process. Lastly, know your climate. Passive house has been very heating climate focused, and certainly an important one. And up here we are technically still a heating dominated climate, but we definitely have many months of summer here in New York and the Hudson Valley, and it's changing. Summertime conditions, humidity especially, is becoming a big challenge for us.
So I can't underscore enough the significance of beginning the conversation about these systems when you're talking about the requirements for a house. And so in the same way that an architect is going to kind of solicit requirements for program type, kitchens, number of bedrooms, number of bathrooms, all the complexities of the project. Cramer and I, we collaborate on a lot of projects, and we put together a questionnaire for clients that seeks to understand what their expectations are for comfort in the house. What temperatures are they accustomed to living in the winter and the summer? But even more specifically, are there other things that they're accustomed to or they anticipate that could have an impact on the design and performance of the system? Things like houseplants that might generate excessive humidity. Do they have collections of computer equipment or analog receivers or something that's going to generate a lot of heat? You never know, and too often we discover these things later, and we have to find fixes for them. Even when I have a basic discussion with a client about how these systems work, specifically about conditioning, about heating and cooling and the relationship to air exchange and ventilation, you have to continue to have these discussions throughout the different phases of the project. You cannot expect a homeowner to understand this in the first conversation, and it just requires coming back to it and revisiting it at every phase in terms of what the implications for in considering these systems. Controls are pretty important because they bear on the complexity of the system, particularly in a climate like where I live, where you have extreme cold and extreme heat, and then you have shoulder seasons where the demands on the system are subject to how it's zoned. And so even though that's getting in the weeds a little bit early on, it's important to begin that discussion early on so people can understand what to expect from the system. Also, if they're moving from what I'll call a conventional house into a passive house, there's a bit of a large cultural shift in terms of what you can expect in terms of comfort, temperatures, and how the systems work. Again, that conversation has to start early. The other thing I want to talk about a little bit is power utilization. We rely on the fact that these systems, when implemented properly, are going to reduce your monthly costs for powering these systems. But very often people bring a lot of peripheral components in that can later on show up on the monthly power bill. And it's really important to understand what these other elements, how they can confuse the efficiency of the system. So these conversations have to start early. The last thing I'm going to say, and it's probably the most important thing, is advocating for space, both for a centralized mechanical room and the distributed area that you need for remote equipment, ductwork. Again, it starts at the beginning to educate the entire team that the mechanical system and the components is just as important as selecting plumbing fixtures and kitchen appliances. They're weighted the same if you're going to do this correctly. Next slide. So very early on, you're going to be talking about architectural form. And obviously, we know for passive house, compactness is a primary principle. And sometimes I like to kind of dumb it down for people to say, well, you get 4 corners. And for every corner that you add, you're adding complexity, both in terms of the number of transitions, the capacity for air leakage, et cetera, et cetera. So my little diagram here on the bottom left is just showing it doesn't take much to get a lot of more complexity. And that's going to bear on the design and the layout of the system. Again, the drawing on the right is just showing a pretty basic 2-bedroom house that Cramer and I worked on with a very centrally located mechanical room that's built in right from the schematics, that's got a fair amount of space and has very immediate access to the exterior, because it's not just the configuration within the building, it's how those components find their way to the outside for outside air, and what the architectural implications are for how those things look when the house is finished. Next slide, please.
So during schematic design, the first thing I'm thinking about is the zoning of all the spaces in the building and what that is going to mean for matching those zones to equipment, heat pump capacities, ventilation needs, and also the architectural concerns. What's the program of the various spaces? Is it a group of bedrooms? Is it the living room? Is it the kitchen? And the varying glazing exposures of these spaces. Does the space have a very strong east glazed exposure, get a lot of morning sunlight, and then sun moves around the building, maybe the big views out of the living room or to the south or to the west, that's going to change the time of day needs of these spaces. And you have to be considering that and thinking about at least approximately what these loads are going to be like and how that's going to match to what the available equipment capacities are. We'll start early conversations if we're going to go ducted or ductless heat pump systems. There's only a handful of different formats that this equipment comes in. There's only two ducted configurations for ducted equipment for most manufacturers. Those are great to group rooms together, but we need to locate the equipment and the ductwork. And what are the airflow patterns like? If they're going for a ductless approach, simple units hung on the wall, much less expensive, but typically they don't come small enough for a head in every single room. A bedroom might have a load no more than 1,000 BTUs, and the smallest single zone system we've got is 6,000. 4 on the multis. So trying to think about load matching and zoning early on is super important to getting the system to work well. There's so many problems out there kind of brewing that I'm seeing. Of people slamming in heat pumps left and right that are oversized, and they're not working well as a result. They're great systems, but they're not magic. We've also want to think about future repair replacement of this equipment. It's going to happen someday. You got to make sure you can get to it, whether it's in a closet, in a ceiling, whatever. But it's got to go. It goes in once, but it's got to get. We got to get back to it. And the most challenging types of buildings here can be if it's a slab on grade and or an unconditioned attic. I do not put mechanical equipment outside of the conditioned enclosure. So if you do not have like a conditioned basement or crawl space or a conditioned attic, which is great for mechanical space, all this stuff is living in your living space. And what space is it going to take up? What closet can we take? What drop ceiling can we add? And what are some of the noise considerations of doing that also?
So in really beginning to understand both the centralized mechanical room and the distributed components, you're gonna have options depending on the house design, of course, and the site for a basement, an attic for the centralized location of all the equipment, and then you will likely, depending if it's a ducted heat pump system or the like, have distributed equipment that's going to require access. And of course, again, the space requirements for ductwork connecting all of these. They all offer opportunities, and they all offer liabilities. I mean, and really anticipating access by service pros for maintaining and ultimately replacing equipment, when that happens, but equally, if not more importantly, access for owners for maintenance, for cleaning filters, and just really understanding what they have is really critical. So all these things go into the consideration of locating and thinking about how this equipment's going to be located relative to the house design.
And one of the things that people don't necessarily understand about these systems, a lot of this stuff is new for us. We might be used to having a boiler or a furnace in the basement of our house now, or what we grew up with. But it's very different systems now. It's not just a single unit or a single system. There's a lot of distributed mechanicals all doing a very specific purpose. In some cases, you can combine certain functions, but at the very least, knowing what services you're going to need in different spaces: heating, cooling, ventilation, humidification, dehumidification. What's the kitchen ventilation situation going to be? Are they using a gas cooktop or electric? Are we going to vent the hood or not? And what's that going to mean for makeup air purposes, which we'll get into in a little bit. So it may be weird, but one of my first conversations with new clients is, well, what's your cooktop going to be, and what's your dryer going to be? And they're not ready for that conversation, but we bring up the basic issues of ventilation and building pressurization, depressurization, especially if you're going to have a fireplace or a wood stove. All of these things interact in very specific ways, and if not done carefully, can have catastrophic effects. If you have a fireplace or wood stove and a uncompensated vented range hood, that can go very bad very quickly. And they need to understand the importance of these systems and their potential interactions, and what this means for the spaces we need around the building to put all this stuff. On the right is a project that Barry and I did, and will probably continue to haunt us for a little while now. That's the one mechanical room. There's a accessible conditioned crawl space underneath the house, which is the only thing that saved us here. But there's an ERV crammed in there. There's a boiler on the left, and there's that empty box is going to become some AV and IT equipment in there also. And this is, yes, you can technically make it all fit in CAD, in 3D, whatever, but the poor guys that have to install this stuff or maintain it or come back in later and fix or replace it. I'm glad I'm not those guys, but I'm trying real hard to make things better for them because they're the ones who actually make this stuff work and keep it running. So we need to do our part to make sure that they can do theirs. Next slide, please.
The one thing, actually hold the slide for a sec. The one thing I just want to say is, I mean, you're never going to hear anybody say, hey, that mechanical room is too big. But what you are going to see is when you're developing, through a set of plans, the mechanical room is going to have some presence on that plan. And when owners are inevitably looking for ways to make other rooms larger, it becomes this thing that you have to defend. And it's a difficult position for an architect to be in, to constantly be defending this mechanical room. And I've certainly failed doing it and lived to regret that. But the reason I talk about the mechanical room size, the potential for expansion, is on this project in particular, there's some complexities that I won't get into here, but we needed to add a boiler for some radiant zones for some peripheral structures on this. Mechanical room didn't anticipate that. I thought we had enough room for everything that we were going to get in there. So this is what I say about a proactive versus a reactive process, and this notion of defending the mechanical room to anticipate what can and very likely will happen during the course of the project. Next slide.
So the single biggest, so to speak, system in most of these buildings and most familiar to a lot of us already are, of course, the heat pumps. Come in 6 different varieties, maybe a little bit more, but you got your 4 ductless options, 2 ducted. Already mentioned those a little bit. But these systems have to go somewhere, and indoor units and outdoor units. On smaller capacities, you might have a 50-foot line set length maximum between those two. And if you're aiming for something like Passive House or other super low load building, you're looking at the smaller equipment out there. So you are oftentimes limited to what those line set lengths are. They're getting better with every generation of system, and it varies from manufacturer to manufacturer. But these are the things you need to be considering early on and where this equipment is going to go. I'm seeing a lot of installers, well, maybe not a lot, but more than I should, installers and advertising for these things really overselling the capabilities of this system. You really do need to do a proper load calculation, review it, make sure you know what it says. I've also seen a ton of load calcs that have been thrown together by someone who doesn't know that the building has a high performance enclosure, for example. And you're still coming up with crazy high numbers. But the systems, they're not magical. They're not infinitely variable. They all have their limits. It's constantly improving. Every generation is getting better. But you need to understand the limitations of these systems and size them appropriately for the loads of the building with the best load calc tools we have available to us. The industry has been pursuing higher and higher efficiencies, generally, SEER and HSPF and so forth. But we're seeing changes happen, especially on the ductless side. They're really basically sacrificing dehumidification or latent capacity to hit these higher SEER numbers. That's great for cooling, but we are often in mixed humid climates here and need dehumidification. So if you're using especially a ductless mini split with a very high sensible heat ratio, there's a good chance you're going to want to add a supplemental dehumidification system to that house, even in climate zones where we typically would not. It used to be just the South that had dehumidifiers, but I'm putting dehumidifiers in pretty much all of my jobs at this point. Lastly, just the zoning, again, bringing the homeowner into that conversation, the space types they're going to have, the expectations of control, and whether they use a lot of single zone systems or multi-zone systems, all has to be thought about early on. And picture on the right is an ice rink developing right next to someone's parking spot in a house that we did. It's also under a carport on the north side of the house, so that ice is there. What, like 9 months out of the year, Barry, would you say?
Yeah, pretty much.
Next slide. ERVs, the other main system in a passive house. Again, that we have some fantastic equipment available on the market, but it still has its limitations and recommended ways that you design and install these things. The standard passive house recommendation is always keep the intake and exhaust ducts short. They have cold air in them. They're basically part of your thermal enclosure. So where is this ERV going to be? What's its access to outdoors like? What's the access from inside like for filter changes and all the distributed ductwork and manifolds that has to go in there? Placement of the exterior vent. This photo is of a ERV intake of an upstate house here. I got a call about 6 months after they moved in. They said, hey, air quality was great in here, and we've been changing the filters, but it doesn't seem, it's kind of stuffy in here. Like, what's going on? So I go up there and we look at it. Yeah, filters have been changed. Everything's running. Go outside and look at the intake vent, and it's sealed almost completely shut with dandelion seeds and pollen and everything. So yes, it's a simple annual maintenance thing, but if this intake vent were, way up off the ground or otherwise inaccessible, that you take what is a simple maintenance item and make it a real challenge if these things are not given some consideration where you locate them. Next slide, please.
So from my standpoint, the remote location of ERVs in particular, depending on the size and the complexity of the house, it's going to happen. And so there are two things from a space accommodation standpoint. One is on the left, that's a dedicated closet for an ERV unit from a house Cramer and I worked on, which was a decent sized house that had a distinct northern and southern exposure. And so the house was approached that way. The ERVs were zoned, one to address the south and one to address the north. And the units had to be remoted rather than located in a basement or a centralized mechanical room in order to keep the duct runs shorter. And then once you get into the duct runs, these other images are from different projects. But no matter what I do, and I'll talk about it in a little while, of trying to 3D model the equipment as a component of the house, it's really difficult to anticipate the amount of space that these supply and extract lines are going to take up. And you really have to anticipate the configuration of them, the sweeps that they need, the separation that they need, and just how they can get everywhere. Next slide, please.
Getting into some of the other systems, kitchen ventilation is a pretty hot topic right now, especially with gas ranges. Particularly in passive house, the push is to cook over induction. It's a lot cleaner, it's a lot safer, lower ventilation requirements. But I'm still in the camp of you should vent your kitchen to outside. We don't have all of the super fancy European versions of all the range hood and ERV integrated systems here yet. Hopefully we start seeing those soon. But for right now, based on what I'm reading about kitchen ventilation, venting it to outside is important. So that means we have to deal with a makeup air system, and we need to talk about the capacity of those things and just the effectiveness of the range hood itself, especially if you're going to have a fireplace or a wood stove in the house. And that's another hot topic of passive house conversation frequently, which we're not going to get into. It's typically a very client-driven thing. And as long as they understand the implications of what these systems are and we can do them properly and safely, it's fine. Next slide, please.
I might just jump in, Cramer.
Yeah.
I can't underscore the issue about kitchen ventilation enough. And this goes back to the notion of getting a jump on the selection of appliances before the construction drawing phase, and really having straightforward conversations with clients about the capacity of vent hoods. Very often they're going to come in when you ask for a first round of selections about kitchen appliances. They've got a large stove with a 1200 CFM vent hood. And so rather than just saying, oh, great, I got a decision, I can move ahead, we have to look really hard at what that means. It's also emblematic of this kind of cultural shift that people don't necessarily understand in a passive house, that they don't need this giant hood. It doesn't take much to pull all the air out of one of these buildings. And so there's a lot of conversations that have to occur at this phase around appliance selection. And if you lose that battle about the number of CFMs in that vent hood, then you're entering this makeup air camp, and that is not that's not for the faint of heart. All right, next.
Yeah, that's a good way to put it. On the last slide, it was just one of the makeup air systems available to us. Yeah, this one here, that's a Fantech 750. It's good for up to about 600 CFM. They make larger versions of it, but even the smallest version here is almost 8 feet long. This thing has an 8-inch intake duct from the outside. I think it should be 10, honestly, if you're really pushing the 600 CFM limit. Fan, filter box, duct silencer, heater. The next slide, please. That's the other manufacturer there. That's an Electro Industries system, also 600 CFM. I don't necessarily have a favorite between these systems. I have my nits to pick with both of them. But if you understand the needs of the space and how these systems work, how they get installed, how they need to be calibrated, that's all super important to be dealing with early on. But it all gets a lot easier if you're just keeping your CFMs to 600 at most, preferably 400. 400 is the code cutoff for makeup air, but in any airtight building, I think anything over 100 CFM is probably going to need makeup air. It depends on the size of the building and the air tightness. But I've had nothing but trouble on the 1200 CFM makeup systems. 600 works just fine, especially if you have a good hood with good capture, and that's something that is being worked on. People are trying to rate the capture effectiveness of range hoods finally. The industry is, I think, starting to adopt that any day now, hopefully. But this is just another one of those systems that needs a place to live. It needs connection to outdoors. It needs maintenance. People need to understand how should be controlled and their importance.
Anecdotally, I mean, on a system where it's too late, you've accepted the fact that you're going to have a significant makeup air component for kitchen ventilation. There are other factors that begin to enter into it. I mean, Cramer and I have had clients who've had a particular sensitivity to the temperature of the supply makeup air, the amount of noise that's involved, all of that. A consideration relative to how the system is configured and how the ductwork is run and how it's accessed. So again, I want to really emphasize that once you enter into this secondary system that has to support a heavier CFM kitchen ventilation hood, there's a lot of work that has to be done to make that work well.
Yeah, and just one last point on these. Even 600 CFM on a mid-sized passive house, your blower door test number is probably less than this flow rate. So these are huge airflows that people don't understand. And in the context of a passive house, if you have a large range hood and turn it on, you're effectively blower door testing that house every single time. So, just the airflow rates here are super important. The ERV might be doing 100 or 200 through the whole house. Your AC system maybe 500 or 600. The blower door test somewhere 400 to 600 on a smallish house, and your makeup air system and range hood blow those all out of the water.
So now we start to move in. I mean, everything that we've just talked about are in theory conversations and discussions that are being had during the course of the schematic design phase, when the basic size and configuration of the house is getting worked out. Entering into design development, when all the equipment is being begun to be specified and selected, this is when I jump in and begin to try to model, relative to the design as it's evolving in 3D, to take that system and begin to configure it. And granted, within the constraints of the 3D software that I use, I can still get a pretty good idea of how the system's gonna lay out from a spatial standpoint. This drawing here, doesn't accurately represent sweeps and turns for ductwork, but it allows me to begin to understand duct runs and what spaces that I need to accommodate for all this equipment. Next slide, please. And then in the same way, this is a little blurrier than I hoped. I apologize, but in the same model, then I'm overlaying it with structure. So in the same phase as I'm working our way towards construction documents, we're coordinating framing and HVAC with similar, they both pull equal weight. So we're not in a situation, which we will inevitably be in later on, where we're going to have to make some calls about conflicts, but going out of our way to avoid major conflicts in terms of the configurations of these two systems.
This is just a shot of my plans post site meeting. Right in my contracts, I specify the site meetings we need to have, and the first one is no later than pre-rough-in. Before they even purchase equipment, preferably, we have to walk through the framed up house, and is stuff going to fit where we hoped it would? Hopefully, mostly yes, but there's always going to be at least minor changes, and these have to be captured in the design. This is residential construction. Typically, it's the Wild West. There's a lot of stuff filtering down from commercial scale construction here with BIM and otherwise, but I get shop drawings on less than 1% of my jobs, and frankly, I'd rather walk through the site anyway, with the architect, with the installer, with the general contractor, and even the homeowner. Does this fit? Does the stuff fit where we need it to? And if not, what changes can we make?
I'm not going to spend a lot of time on this. My real point in showing this drawing is that it's not uncommon for a full coordinated set of drawings to be sort of torn apart and distributed to different trades on the site. So I tried to do a summary drawing that speaks to the mechanical engineering drawing in terms of overlaying all the equipment, has a three-dimensional diagram of the system, but also articulates the air sealing details in terms of penetrations through the envelope for pipes and conduit and wires, just to get all that information in one place so it doesn't get lost. Next slide, please. I'll start this one, Cramer. So Cramer made reference to the pre-construction walkthrough. This is a photo of just such a thing when everybody was assembled to walk through, including the contractor, the engineer, the architect, and the subtrades. And it's just, again, my job as the architect, and I generally hire somebody like Cramer as my sub-consultant. My job is to really keep them posted on the progress of the work, and to let them know when so they can anticipate in their schedule having the time to come out, to be part of this meeting, and then to be monitoring the progress as it moves forward.
As things are being installed, we've got to keep an eye on it. Nothing ever goes 100% as planned in construction. So there's minor shifts here or there. Things may or may not fit where we need them to. Flex duct gets squished in between structure, all sorts of stuff. Are we catching these things in time to make sure that the systems can still work? In Passive House, we're to talk a lot about blower door testing, doing at least one early. I do a lot of my own blower door testing, because if I'm going to do a tight mechanical design, I need to know that we're actually going to have a tight enclosure. Same thing goes for mechanicals. Duct leakage testing may not be required by code, but if you have extensive ductwork all around the house, you should leak test to make sure it's actually going to deliver what you need it to deliver. Even down to the final punch listing. Are the grills installed what we're spec'd? Yeah, I've seen plenty of substitutions of a wall grill for a ceiling grill and vice versa. It's like, well, that's not really what that should have been, and we make sure we get what we designed, and then what we designed actually works.
Just a second on this. It's just really, again, putting careful thought into the consideration of exterior components. Yes, so they work, so that extract and intake are appropriately spaced from each other. The relationship of those to makeup units, to roof vent stacks, condenser locations. We don't want surprises when this stuff comes in. It's very difficult to move a condenser when an owner sees it for the first time, during a walk around during construction. So, getting out ahead of these exterior considerations early is just as important. Next slide, please. I'll just start off by saying I think Cramer and I both worry a lot less about whether the system's going to work. We worry more about once we're gone, or at least once we're not on site on a regular basis. Do people really understand how these systems work? Do they understand what kind of maintenance is required, and are they working effectively? I'll let you talk about the slides, Cramer.
All I want to say is change your filters. Change your filters, change your filters, change your filters. I try to locate equipment where it's accessible. As soon as it requires so much as a screwdriver or a step ladder to change a filter, it doesn't get done. So we talk about this with the homeowner. If they're going to have a maintenance contract, try to make sure that that team knows what they're doing. A job recently where the installing company sent the maintenance crew and had no idea what an ERV even was. That shouldn't be happening. It's super simple, but it needs to be covered and needs done regularly.
I think we'll be quick about this. It's just really obvious that there are fails in terms of maintenance access. And next slide.
Yeah.
There's the possibility of success on the left, two spaces under construction where we've been pretty straight up about access to distributed air handlers and a finished kitchen on the right that has an access panel for pretty well worked into the ceiling scape. Next slide. Yeah, go ahead, Cramer.
Just we've touched on a lot of this stuff already, but we don't have this 100% figured out. This is kind of an evolving thing in an evolving industry and climate. We need to recognize that there's some stuff that we're not going to be able to catch, but that's why we go back and check how these buildings are working and talk to the owners once they've moved in. How's the maintenance going? How's the comfort? What are your utility bills like? There's always something to learn from every project, and if you're not learning from each project, I don't think you're taking every opportunity that you could be. So yeah, this was not how it was drawn, but that's how it got installed, and this is why I do post rough-in site visits and get up on the roof and say any number of colorful things about some of the things I've seen. Yeah. Next one. This was not one of our projects. It almost was.
Neither was the last one.
That last one was one of mine.
All right.
Just if you don't want this kind of crap on your roof or outside the building, plan ahead. Involve an engineer or mechanical planner of some sort, just avoid this sort of crap. Another one, not my design, but a project I was asked to come to take a look at things. Notice this, the boiler exhaust, which is acidic, flowing out right over the condenser, dripping down into it and eating right through it. That condenser is probably already dead. This was 2 summers ago. I'm sure that condenser's been replaced already. Just plain stupid placement right there. And then last slide. This is a text I got from one of my favorite general contractors to work with. I think he's got the right attitude. Yeah, and that's me on the right, reading the manual of all things. Imagine that.
I think that does it for our presentation.
Yeah, Barry, anything else?
No, I really just want to emphasize that I can't underscore enough, planning as early as you can and educating and sharing information with owners from the first conversation.
Yeah.
Well, guys, thank you very much. We appreciate your time, and your work speaks for itself. Let's give him a round of applause. The Hudson Valley stole you away from me, Cramer, so I don't get to work with you that often. But you can follow Cramer on Instagram and see all his what were they thinking photos, which I always personally enjoy. And Barry, keep up the great work, and your very thoughtful 3D models are very much appreciated, and your architecture style in the Hudson Valley, paired with high performance and great mechanical systems, is what we need to change the world in our neck of the woods. So we have a ton of questions that are up there. My personal comments were, it's great to see 2 professional gentlemen that embrace the building envelope and high performance mechanicals and are truly solving problems that we face in our future and in the buildings that we're designing. I personally worked with Cramer on a few projects where we're trying to integrate fireplaces and overcome dryers. And they're not easy problems. And I think Cramer says you only get 1 or 2 maybe or so, but you can't get all 5 major problems and expect us to solve them. But we'll go to questions, and thank you, gentlemen, very much. I appreciate it. We all appreciate it.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Aero Aggregates, Brennan, Brooklyn Solar Works, Euroline Windows, Coltraco Ultrasonics Micro Air Leak Detector, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
Excellent. Okay, we got about 7 minutes for questions before we kind of wrap things up. So my first points, just want to say is, love the Mona Lisa comparison. I'm going to use that in pretty much every future meeting I have with clients to make sure that we clear on the expectations. I love that part. And I know Monty's Passive House pattern language course, he really talked about, you start a project, ideally get the mechanical room on the plan first before you do the fun kitchens and en-suites, kind of give that space. And also about, again, we had Gary Klein on, and having that mechanical room also then helps define where water lines are and trying to keep things short. So really good point. Kind of first question I'm going to take over is, that one room you had was kind of like a 5 foot by 5 foot. And I feel sorry for the mechanical trade that had to get in there to do all that work. Is there a bit of a rule of thumb that you guys try to start with, Barry, in your designs? Like, do you say, okay, I'm going to start with a 6 foot by 8 foot and try to grow? Is there like a kind of a plan set that you kind of, rule of thumb that you try to start with, given that you've done a few of these?
I mean, no, I that's a good question. I mean, it's a matter of proportion. When you look at a plan, if it looks too small on the plan, it's too small. If it looks too big, well, some people would tell you it's probably not too big, but a client's going to think it's too big. So, I mean, generally, it's roughly the size of a bathroom. 5, 6 by 9 or 10, I would say, to start. Again, it depends on the size of the house, the geometry, and how it has to stratify, vertically. So, but that's the quick answer.
There, Reed, architect. Yeah. There. Oh, go ahead, Cramer.
The quick answer is more.
Yeah.
All right.
Bigger, more. But also it's connection to outside, ERV intake and exhaust, boiler in and out if you have one, makeup air intake. A space buried at the back of a basement with no access to outside, no matter how big it is almost useless. But a couple of small closets scattered throughout can be a lot more useful.
Great.
That's right.
Great stuff. Okay. And then we'll head over to Steve K.
Yeah, you guys did a great job of talking about the ventilation for the kitchen. And I'm just wondering a bit about the controversy, if you will, or the discussions I've seen about ventilation location for the ranges. I've seen some things about not having the ventilation over the stove or range on an island, and more so putting it on a wall. Any thoughts on that?
Well, I mean, there's more than HVAC considerations in terms of, having ventilation over an island and having a cooking device, over an island, but that's more about adjacencies to other spaces. No, I don't. I mean, I generally try to avoid ventilating over islands just because of the complexity of getting the equipment to the right place. But from a performance standpoint, I don't think I could give you an articulate answer, but I do try to avoid it. I do try to keep the appliances, sort of attached to a wall when I can.
Yeah, they're more effective when they're at least against the wall. They'd be more effective if we could put two sides on each side. They'd be even more effective if we could put one in the front and turn it into a fume hood, which is really what it is.
Yeah, limiting the catchment area.
If you look at the HVI recommendations, it's a higher airflow rate recommended if you're on an island instead of against a wall, just because of the capture efficiency.
Harvey asked, could we discuss EnerFit and how your approach may differ from a regular house? That's his first question. We'll give that to him.
I don't have enough experience with the certifications. I've done a few, but I couldn't give a good specific answer to that. For me, the principles remain. I think you do the best you can, regardless of what kind of certification level you're seeking. And so for me, honestly, it wouldn't make a difference.
Yeah, there might be other constraints in an EnterFit, but it just makes it even more important to discuss everything early on, where equipment's going to go.
Harvey, we'll come back to your second question in a bit. We'll move over to Brad. Brad's question was, is it best to have mechanical room on a north exterior wall? And I guess we could say that is going to be north of the equator. Would that apply? And I guess reverse if it's south of the equator.
It tends to happen only in an effort to really maximize the exposure of the common living spaces to natural light, south, east, west. Tend to group smaller, utilitarian spaces to the north. Though there is value in bringing north light into a house, but that would be the reason why I would do it. Cramer might have another.
Yeah, no, that's the standard passive house approach. I mean, outdoor air is outdoor air, whether it comes from north, south, east, or west. So the ERV doesn't really care. And yeah, traditional passive house design is put your living spaces and the glazed spaces to the south or to the sunny side, and mechanical, et cetera, to the north, where you should have less glass.
But spacing between condensers is always important.
Yep.
Well, thank you guys. Any more questions? One comment I'd like to make is just training. We really, as a group, need to advocate training to enroll in these mechanical contractors into some sort of awareness training. They should know the basics of passive house. They should know kind of the rules of the game, what EnterFit is, the certificate, what the testing responsibility is. It's all too often where me personally, I'm on site coaching the HVAC contractor, like, hey, you're going to need to add a lot of duct insulation around that, and you really seem to not have enough room. And I think we need to do more of that training up front. And hopefully this next year, when we're getting back to life as normal and doing in-person training, we can organize some workshops or something. So it's something I personally want to work on, and I welcome you guys to give your input. But Cramer, you've always been a great advocate of training and on-site discussions with contractors. And if you guys have any thoughts on, do you think the contractors you work with would take a training if you kind of required it or put it in the specs or so, or they just kick it down the road?
Some have, at the very least, just involve them and tell them why this house is different and better. And that the good ones want to learn and do better every single time. You have to give them that opportunity to do that. Don't just tell them to insulate that duct. Tell them why.
When we're certifying, we make it a requirement, a contractual requirement that some representation of the construction team has training. So there's always somebody on site that has that expertise.
Yeah. And a catchphrase I always use, those that teach the most gain the most trust on the site. And I know when I've been on sites with Cramer, he's always teaching, and all the questions seem to get kicked up the chain to the person who's answering the questions with a thoughtful response. So where else are we? I see in the chat, and I know that my friend Ben is doing training up in Troy, New York, teaching the Passive House Tradesperson course with EMU, doing great work out there. I think there's other opportunities that are coming out there. Do we have any events? I know it's the top of the hour.
Yes, we do. Kevin, thank you so much. And I just want to remind everybody that Barry and Cramer did agree to stay 15 minutes late, so or 15 minutes after 1 o'clock. So if we can get through some more questions, we will. Starting with a few quick events, we have episode 123 of the Passive House podcast for you, featuring Tessa and Rusa, co-owners and principals of Artisans Group based out of Olympia, Washington. Next up, we have episode 1 of season 2, Building Performance Interactives. This will be tomorrow, 9 a.m. Eastern. This is a partnership with Partel, based in the UK. So it's a little early for those of you on the West Coast, but hopefully you can watch the recording. I will put the link in the chat for this. Next up, we have 10 steps to designing your first passive house. This will be the first episode of our 101 series next Wednesday. And this is at noon Eastern, featuring Michael Ingley of Baxter Architects. Next up, we have a Passive House Component Spotlight. This is next Tuesday, January 31st. We have Coltraco Ultrasonics joining us, and they will be discussing achieving passive house levels of airtightness with the Porta scanner airtight. And finally, a reminder that the 26th International Passive House Conference is taking place in Germany, March 10th and 11th. And this will be a hybrid event. If you can't make it in person, I will share all these links in the chat and send it back over to questions.
All right, everybody. It is top of the hour. So if you do need to go, we appreciate you coming. Be back next week. Again, there's lots of great events happening next week on the Tuesday and the Wednesday. But we've got a new segment. We're not going to go in the overtime because we don't have 30 minutes, 45 minutes, hours that we used to. We only have 15 minutes. So start the clock, Kim. The bonus 15 starts now. And we got Wayne Robinson. You are kicking off the bonus 15. What's your question?
Yeah, just a quick one. I mean, the problem we have in the UK, the developments we've done, one is fire blocking, obviously, trying to stop smoke and fire and smoke. But the main thing we found is you need to allow for educating the users, because they're not, the estates we did, that they come in, and if it's cold, they still feel as if they just put a fire on or something, or warm up, or if it's too hot, they're open a window, which is sort of goes against waiting for the system to sort of kick in. I don't know whether you've experienced that or whether that's.
I mean, I would say the equivalent. I mean, it's really what I referred to as kind of the cultural shift of moving into this kind of house and people leaving some of their responses to experiences behind. What their expectations are for temperatures, the responsiveness of the system, even, how it even goes back to how big of a vent hood they think they need versus they actually need. The necessity for fireplace, a fireplace for atmosphere versus actually warming up the building. So that all just comes back to really managing expectations from the beginning. But that doesn't mean that they're not going to default to how they're used to living in a house. And that's where it gets difficult when we're not there on a daily basis to address their questions. So it really just comes down to really having the conversations about what their expectations should be about the house from the beginning. But it's difficult. Yeah. It's really difficult. I don't have a good answer for you.
Yeah, it's a true. Yeah, it's mainly on social housing where they don't really get a say. It's they just move them in. They just tend to carry on as normal. But yeah, I mean, that's just thought I'd share that with you.
Appreciate it.
Thanks, Wayne. I know you had other questions, so we'll come back to them, but at least you got one in. I see that Sandra's left us, so we'll go to Lindsay because she's there ready to go ahead. So, Lindsay.
Hi, thank you both very much. My primary question is regarding dehumidification with an ERV, with a central heat pump system. Because you say you're using dehumidification a lot more. Are you adding dehumidification to a central heat pump and an ERV?
It's in process, yes. I might be retrofitting a dehumidifier onto a couple of ERV systems. Going forward, I'm trying to have dehumidifiers operate either independently or tie them into a ducted mini split heating and cooling system just to utilize that distribution.
In addition to the ERV?
Yes. Well, the ERV doesn't actually do any dehumidification, which is what a lot of people don't understand about them. It's merely working to preserve the difference you have between inside and outside that some other system is providing. So if an AC, it's bringing some dehumidification, hopefully ERV helps preserve that, but an ERV does not provide any dehumidification on its own. In fact, it's a humidity load. It's less than it would be if it were an HRV or uncontrolled ventilation. So ERV is the best way to do it if you're in a humid climate. But even then, you may still need active dehumidification, whether connected to the ERV, the heat pumps, or preferably fully independently ducted, just recirculating its own indoor air so it can operate totally on its own. But there's a few different ways to do it depending on the space and other requirements.
Thanks.
I see a few of our friends from Australia and New Zealand have departed. So if you woke up early, had your alarm on, and you're getting your first cup of coffee and you're parting ways, thanks for joining us. We appreciate the getting up early because, again, with the time change, we thought we'd lose a few people. But you diehards, get up for everything, which is great. So we appreciate you. All right, Nilton, over to you. You're next in the queue. Fire away.
Yeah, hi. So I have a question. The reason we have a lot of heritage homeowner want to install heat pump, and I did heard you mention that the distance between indoor outdoor units is better being within 15 feet. Is there any way to walk around because they got rejected because they were put on a street facing facade? Or is it possible to screen the outdoor units if that's another way to not really affect the heat pump capacity?
Well, the line set limits are set by the manufacturer, and I've seen as low as 50 on the smaller systems, up to maybe 1 ton. And it varies from manufacturer to manufacturer, and it's all going to change again probably with the refrigerant changes coming. But you're not really supposed to extend them beyond that. Screening of outdoor units, the short answer is no. The longer answer is yes, kind of, if you're careful, but no one gives you any actual recommendations for, net-free area or anything like that, beyond basic clearance requirements given in most install manuals. They move a lot of outdoor air. So as long as they can still move a lot of outdoor air, it's fine. But where the line is between a lot and not enough is no one can really tell you.
Okay, Clara just left. So Israel, you have the floor.
Hello, I just wanted to know if either of you recommended integrated mechanical systems for any of your projects, and if not, did you consider them?
I have not used anything that I guess you would call an integrated mechanical system yet. We have a couple of options here on the North American market. I just haven't had a project that I felt like was a good candidate for them yet. There's some interesting stuff out there, and I'm looking forward to seeing more, particularly the stuff that we might be able to bring over from Europe, these so-called magic boxes and things like that. Hopefully, as the markets develop, we get more options, but I haven't really done any integrated systems yet.
Generally speaking, I think we're pretty careful, about wanting to try things, but wanting to have the right client to try things with. If we had a client that was really motivated, to be on the cutting edge of systems, we'd be more inclined to try it. But it's hard enough to really get people to adapt to the systems that we're working on. So we're pretty considerate about that stuff.
Dan Shoemaker, it's your turn.
Yes, this is with response to Aaron Woods, who was asking if I could hang around and just talk about a wish list for a next generation range hood, and just to share some ideas. But the concern is it doesn't matter the size of the house. If you've got a stove and you're cooking something that's got some things that need to be vented, it doesn't really matter how big the house is. You've got the same sort of situation. So it's kind of a really key element. I think everybody would agree with that, even if it's a small apartment or a large house. This is the sort of thing. It just means so much makeup air. So what to do about that to reduce that? And I'm thinking about the space that's in the cabinetry or above the cabinetry out to a wall, and that's feasible even with an apartment, although much easier for a freestanding house. But I have an idea for like a wetback kind of mediation as a way to get the noxious fumes to a state where they can actually be captured with a filter without a great deal of air, going through. So you're not even talking about connecting it to the outside, and then all that system being readily accessible in a drawer. So in fact, if it's a matter, even if you, it's the sort of thing that can be done at the same time. Or after you've done some, some substantial cooking. And again, so here I am. I'm just throwing these ideas as a batch more, but
no, all good there, Dan. I think you and Aaron need to connect. I know he's got a pretty interesting box that's brewing. So you connect with Aaron, and I know you two, and then the rest of us can share some of those good ideas. But he's got something in development that I can't wait for him to bring it to market, because I know all of us will be looking at putting in our future Passive House project. So I'll let you guys two connect, and we'll move on because we've got 4 minutes left. And next is Mike Lind. First question was ERV ducts on opposite sides of house and wind pressure causing a pressure differential at the ERV. Have you ever had that issue where you're trying to separate things, but you got some wind issues?
Never put them on different sides of the house, so I couldn't say.
All right.
Yeah, if I were on a really windy site, I'd be concerned about doing that, but generally they're on the same side, 10 feet apart. But yeah, on a windy site, that could be something to consider.
All right, excellent. Good rule of thumb there. Other question you had is can a radiant heat and cooled geothermal system work in a cold climate if a dehumidification is incorporated into the system? Not exactly sure we would want to do that in a passive house, but
yeah, I mean, air to water is on the horizon for us right now here in the Northeast. It's very interesting stuff coming. In a house, especially where someone's going to leave a window open or something, I'd be very concerned about radiant cooling. That's more of a commercial approach where you generally have a sealed envelope and more sophisticated control systems. I would still do cooling with an air handler, coil of some sort, because it's going to get wet.
All right. Okay, Mr. Harvey. You're not asking the Harvey question. You can ask her another question. The floor is yours. Thanks for coming back. Harvey?
Sorry, just got from the gym. It was great to listen to the gym, so it was fabulous. Just a real quick question. What's your thoughts on your approach if this is an EnerFit versus of being a new build? Thanks, guys, and a great presentation.
Oh yeah, you missed that. While you're pumping iron, they did answer your question. So now they're going to repeat themselves and waste a minute of our lives because you were
okay. So then can I go to my second question?
Short answer is there's no difference.
Okay, perfect. And then thank you for that. The other question is, what's your thoughts on the Rheem heat pump domestic hot water tank? I don't know if you touched on that at all.
I've heard the particular generation of them was a lot noisier than previous, and that's been all over the internet message boards. I don't know if they've resolved that yet or not. I rely on installers and homeowners to keep me updated on some of these different brands of how well they're actually working. But by and large, most heat pump water heaters are the same, but every so often one's a little noisier, one has a control fluke or something. It's a great technology, but it's not fully mature at this point, I would say. Some plumbers don't even still know what they are, unfortunately. I learned yesterday. Yeah, but it's too hard to keep track of all the different models. They're changing every year.
Yeah, and I know that Brantford also has another one, so people have kind of priced up both a Rheem and a Brantford models.
Shouldn't it be a problem in the energy mix because they're taking heat and putting it into the water?
They do cool the space they're in, but if anything, these passive house buildings have more heat than they need. So I welcome the cooling and dehumidification you get from them, especially in a passive house.
And Cramer, on those particular projects where you've had that system, have you also seen where they're putting the IT equipment nearby? So you've got the heat coming off the IT equipment that then is being pulled into
Yeah, we haven't done that deliberately necessarily, but yeah, the heat, the otherwise useless heat gain off of IT equipment and otherwise in the same closet as the heat pump water heater. Sure, why not? Don't bend over backwards to do it, but that's cool.
Got it. All right. Okay, Barry, Cramer, thank you for your time. Everyone, yeah, the bonus 15's over. Done. We're out of here. So thank you very much for joining us. Again, great to see so many lovely faces back. And again, the technical techniques and technology, we're back in 4 weeks. Again, as as much as Kevin wants us to be on the 3rd week, we are actually on the 4th week. And so stick to the schedule. For those that I've been here for the first time, next week, we can get a little dialed down for how nerdy we got, because Michael Ingui will do the 101. And so if you wanted, again, a bit of a understanding of what Passive House is, he will do it. And if you're not familiar or you want to start teaching it, show up so you can learn all the right proper language that Michael uses when he's out promoting and getting clients to jump on the Passive House train. So join us next week. Crazy that January is coming to a close and we're in February. Where did January go? So Zach and Kim, I'll let you guys close things out. Shannon, Mark, and Kevin, always great to have you guys here. Great episode to kick off 2023.